Hey, good morning, everyone. Thank you for taking the time to attend our webinar today on Trimble Mobile Mapping. I'm Angie Swirski, the Mapping and GIS Sales Manager at NEI. Also on the line with me is Justin Brooks as well as Justin Terrio. They are both with Trimble on the mobile mapping side. And we have Tammy Peterson. Tammy's the VP of Sales and Marketing with Solve 3D. So before we get started, I'd just like to note there is a box for questions in the webinar window. Feel free to drop anything that you might have. We will have time at the end, of course, to answer as many questions as we can, and I will be sending out a link to most all of the information presented, as well as a link to the webinar recording itself. So on that note, we'll go ahead and get started. So today we're going to cover the following, why mobile mapping and how you can put it to work for you. We'll go into a quick overview of the Trimble mobile mapping product line itself. We'll also outline the workflow and show a couple of data sets so you can really see the data qualities that these systems produce. And last but not least, Tammy will talk about the Solve 3D solution and how their product can greatly aid in visualization and collaboration. So this is the reaction you might get from your field crew when you tell them you landed a contract to collect miles of data, let's say 150 miles, and you have to deliver all the assets, meaning the roads themselves, signage, manholes, handholds, light posts, transmission lines, and you have to turn it around to the customer within a few months. Their reaction might change and you let them know you've invested in a solution that is efficient. That is efficient, accurate, much faster, and at the bottom line, much safer. I really want to hit on the safety factor. You don't have to, using these systems, you don't have to shut down the roads to reroute traffic as you might have with traditional methods. So you not only keep drivers safe, but you keep auto congestion to a minimum. You keep your road crews away from surveying directly on busy intersections or in the interstate with, cars and tractor trailers whizzing by sometimes at 70, 80 miles per hour. So why invest? For one, you want to grow your business and your bottom lines. Mobile mapping can certainly help you accomplish this. This is an industry that has been growing steadily over the last decade and become 100% an accepted method to meet and exceed project requirements. And of course, add the value to work that you may already do. With growing your business, you expand the ranges of services you provide, truly offering tailored solutions to your customers. Deployment is quick and easy. If you have to ship the sensors across the country, there is minimal setup time for those crews. They'll be off and running in no time, improving that operational efficiency. As I mentioned in the last slide, mobile mapping has become ever more present. It can only help secure more projects in the future. One example I have of this is the ADA compliance measures that the feds have put out. I think it has to be in place by 2023. I could have that date wrong. But mobile mapping, is an ideal tool for this. So, I could probably do a whole a whole webinar just on this alone. But if you want to know more about, what those guidelines are, feel free to contact me offline. So one of our US-based customers shared with myself and Trimble what their small shop did. They did multiple projects to the tune of just under $500,000 in a year. And on that alone came out, just with $300,000 in pure profit. They also shared that some of those, jobs had a 40 to 50% return alone. Again, I've mentioned it before, but you can cover a lot more area in a shorter amount of time. This isn't limited to just driving the roads. You can also mount this to an ATV for areas you can't reach by vehicle. And you could also mount these systems to a boat to do bridge, port, and coastal scanning as well. So this leads into staying ahead of your competition. We all have it, and finding that competitive edge is necessary for growth. So first, we're just going to briefly outline all the systems if you're not familiar. The first one we'll outline is the MX7 mobile imaging system. It has just the basic specs. It has 5 6-megapixel cameras for a 90-degree field of view, an integrated GNSS INS that can get down your accuracy down to 2 to 5 centimeters. The images on the right side are from a utility customer in the Florida Panhandle, just kind of showing how they have the system mounted on one of their company vehicles. And then just, a grab of the system itself, it is an integrated all-in-one. I also want to mention the ease of use. The system isn't operated off some complex computer. It's simply an iPad or, some sort of tablet that the passenger uses to control everything. Of course, there are many applications for a system like this. I could hit on all of them. But, looking at visualization, 911 addressing, rail network management, asset management. The list goes on. You can all the way, go all the way down to, survey and surveillance and security, to name a few, architecture and city planning. So there really is unlimited options for a system like this. So just to talk about one small application with disaster management, a few years back, Trimble was collecting some MX7 data in the Florida Keys with a customer. So here's a map just highlighting the trajectory that they drove. So when Hurricane Irma hit in 2017, they went out and drove that same trajectory. I'll show you on the next two slides how this is valuable for disaster management. So here's a before and after image of some damage caused by Irma. I mean, you can clearly see the down signage and the debris. I mean, from this imagery, the cleanup crews can assess the volume of debris that needs to be removed and deploy the proper amount of vehicles and personnel to assist the efforts without putting, the workers and the cleanup crews directly in harm's way. And again, here's another before and after. I mean, you can clearly see the broken power line. I mean, this would definitely pose a concern to the safety of that area, as well as those same cleanup crews, but also allows the utility company to ensure they have what they need when they deploy their field crews to get the power restored. So the next one is the MX2, which is a LiDAR system with an integrated 360 camera. So this slide shows the system mounted to a nice looking Land Rover. You can see that, on the roof mount has the system itself with the secondary antenna, the pod, the camera. And then down at the bottom wheel is the DMI, the distance measurement instrument. If you're not familiar with that technology, it greatly helps a system like this in areas where GNS outage could be a concern, like, say if you're in an area where there's a lot of tunnels. So, adding that component to a system would definitely be valuable. So I'll just touch on some facts about the MX2. There are two 360-degree rotating lasers, as well as, like I said, the 360-degree camera. You can capture upwards of 70,000 points per second, all while maintaining survey-grade accuracy via post-processing. It is rugged enough for off-road use. To build on that ruggedness, it has an IP65 rating, so it can be exposed to certain amounts of dust and water without concern for damage. It's also easy to install. There are no complex computer racks. I mean, gone are those days of taking up the back seats of a Suburban to accommodate, those large systems. And, this system runs off a laptop, again, easy to use. Again, like I said, simple. Installation with minimal cabling, operate the camera and laser simultaneously. And, it's a very simple design. There aren't a whole lot of moving parts to worry about. So where would the MX2 fit? I mean, there is the survey, utilities, telecom, and general mapping markets. Some folks work within one or multiple of these, multiple segments in more cases. The sweet spot for us with NEI has been in the telecom business. I mean, if I had to ping it, I would say 85 to 90% of our customers that use the MX2 are in that market specifically. And, they're also running multiple systems. The main focus the past couple of years has been the 5G expansion. It's been keeping them busy. I mean, even now with everything going on in the world, they're able to work and still share their data with their analysts that are working from home. Just a side note, I just had another customer tell me yesterday that they were able to collect some great data in an urban area. And since most people are on a stay-at-home order, so they didn't have to really, filter out a lot of that car and pedestrian noise that usually comes with scanning those, densely populated environments. I mean, unfortunate circumstances, but it was really nice to hear that feedback. Here's another slide a customer shared with me. They mapped an interchange and used this data for their design project, which included a complete redesign of this area to make traffic flow a little bit better. I guess this was a site that had multiple car crashes, beyond a number that was beyond acceptable. So this is a way for them to collect the data, design it in the office, and then pass it on to the contractors that actually did the job. So a user in Georgia shared this with us. I like to show so you can actually see the cost savings over time, going from a traditional field collection workflow to investing in a mobile imaging workflow. I mean, I won't break this down in detail, but they did do 25,000 10th mile segments, and just, factoring in the cost that they paid for their crew versus the cost of the MX2 crew, they were able to save just under 170 a year when, just on those 25,000 segments. So they were definitely happy that the money that they invested was worth the return that they got. So on that note, I'm going to turn it over to Justin Brooks, and he is going to talk about the MX9 and dig into some data. Justin, it's over to you.
All right. Hello, everyone. I'm Justin Brooks with Trimble. And Angie, can you guys see my screen okay there?
Yes, I can.
Brilliant. So I'll dig in a little bit to the MX9. It's our premier mobile mapping system on the higher end of things. As Angie mentioned, it's very easily mountable. So, I mean, we've put these things on anything from an SUV to a pickup truck to even golf carts and side-by-sides and boats. Anything basically with 2 parallel bars can mount this rack here. And then the computer unit would go inside the vehicle, and there's really just the one umbilical cable that needs to attach to the system outside. So it's very easy setup, very quick and light for a couple people to lift, usually a 2-person lift. They have these 2 handles on the side, so it makes setup usually less than 5-10 minutes once you have this roof rack attached. Now, on that note, a lot of the components that will come with the MX9 include the control unit, which will house 2 2-terabyte drives for a total of 4 terabytes total. You have the options for GAMS and DMI. DMI is that distance measurement instrument that Angie mentioned, and GAMS would be essentially a second heading antenna, and both of those are ideal for GNSS denied environments, or especially on anything where you have a limited movement like a rail and things like that. You have the roof rack itself, which has a very rugged mounting attachment system and all redundancies built in, so you can kind of make sure that that system is locked in and not going anywhere. And then you have a power unit that is essentially going to streamline power coming straight from the vehicle and into the MX9. So there really is no need for backup batteries and things. Although, with that said, if you're hooking up the system on a boat or a golf cart, for example, you can use a couple deep cycle marine batteries in parallel to also operate the system. Now, it is also worth mentioning that this is a kind of BYOD when it comes to operating the system in the vehicle. You could use either your phone or a tablet, or you could connect directly through Ethernet with a laptop. But essentially, anything that has the Wi-Fi capability, you'll be able to operate the system with, which keeps things fast and versatile in the field. Now, with the MX9, it's built to be able to scan at highway speeds. So each of these scanners is pushing out over 1 million points per second for a total of 2 million, and I believe 500 lines per second scan speed. And you have the option of utilizing either an Applanix AP40 or AP60 IMU. And we could dig deeper into those differences later, but basically the AP60 will be faster initialized in the field and will hold its values longer if you're going through, for example, a long tunnel or under a dense canopy cover. So on that note, there is 8 total cameras. You'll have 6 with the Ladybug 5 spherical camera up top. You have 2 5-megapixel forward-facing cameras, and you also have a rearward-facing pavement cam in the back. And actually, I have a unique application to show off here in a moment regarding that pavement camera. And if I failed to mention it, these scanners are actually Regal VUX1 HA scanners, which are on the higher end of the mobile mapping market here. Now, also, we have the option to utilize 2 scanner setup or a single laser setup. Now, when you're doing the single laser, you have the options to be able to adjust the orientation to change the angle of your scan. Note, when you're doing this with a single scan, you're really only going to pick up a single face of multiple objects, especially if there is traffic and other obstructions in your data set. This is really when the X pattern of the VMX shines through, because you'll then be able to hit it forward and backwards from your driving direction and capture 3 sides of each object. And that'll also help eliminate shadowing from traffic and other obstacles as well. So having the dual laser setup definitely saves you time in the field, but we also have customers very successful with the single laser setup because the density is still there. So it really just depends on what is more important as far as the data quality, data density, and time savings in the field. But note that we have options for each. And here you can kind of see the differences here with left and right laser and then combined. But I believe once we get into the live data run through, you'll be able to see this a little better here. Note that in TBC, Trimble Business Center, where a lot of this data is going to be funneled through, we have the capability to not only process and visualize the data, but then register it down to survey control to make sure you have that absolute accuracy that you need. And then you're actually able to classify and export that data into industry standard formats, essentially, for extraction softwares. So, but the the classification side can be done right in TBC as well, which is very helpful and can kind of help streamline things going forward. Where if you only need to pull out, for example, the road surface, then you could remove all the buildings and vegetation and poles and signs and only export the ground data to kind of streamline data management and move things along faster. And here's a nice photo of some data in the city. And a quick recap. Again, you'll collect data in the field on your own tablet or device. You'll process it back in TBC, also utilizing a Planex's pause pack to adjust the trajectory. And then finally, you can export and deliver this data in many different types of industry standard formats that can be pushed out into ArcGIS and Esri and really anything else that you guys might be using in the back end. Now, with that said, there's depending on the application you guys are approaching, there's softwares optimized for those different applications. So rail is very popular along with utilities and telecom, as Angie mentioned. But I'm going to run through that quickly because I'd like to show off some data live. Now, first things first is the MX7 here in TBC. This is the imagery only, but even pulling from imagery only, you can still extract line work and throw in points and things as needed. And again, I'll go through this really quickly here, and we could always dig in deeper if you guys want to later separately. But you have a couple different options when it comes to picking points or creating lines, essentially. And you could utilize this spatial picker, which will essentially use two different photos to kind of triangulate the position of an object. And then with that, you could have those points then mapped right on the 2D plan view here. And also with that, you could utilize line strings and the ground picker view. Instead of having two different photos to triangulate the position, you could actually use the system's height from the vehicle and then create line work on the ground. Now with that note, with imagery only, it is going to degrade accuracy the further away you get from the vehicle. So take note of that. But I mean, it's quite easy that even with these parameters to keep it within 10 centimeters, 20 centimeters or so, if you maintain good data collection practices in the field. Now, as far as the MX7 goes, usually people will bring in the imagery, kind of analyze, QC it, and then export it from here quickly into extraction softwares like Orbit GT / TMX. But that's kind of a quick overview of some of the tools here that TBC has to utilize with the MX7. Now, on the side of the MX9, note that you have the imagery along with the LiDAR. So you're able to not only have a 3D view of the laser point cloud, which then you can make measurements from and extract information from, but then you'll have the photos as well, where you could overlay the point cloud and take measurements right from the photo. And here you could also see that we have some survey control on certain projects. And I don't want to dig too deep into the actual workflow itself, but just note that TBC follows this very simple left to right type workflow. So as you come in, if you forget a step along the way, just kind of follow this toolbar up here and it'll help guide you along. Usually the first step when you're bringing in data is to obviously select your coordinate system, generate the scans, either register the scans to survey control or cloud to cloud to itself for more of a relative accuracy. And then you could also colorize and update these scans and or classify them. So for an example of the classification, you can kind of see here how the different colors designate different types of data. We have specifically ground, buildings, vegetation, poles, signs, and power lines. And it's able to pull all that out essentially automatically. And you can see here in this point clouds tab, classify regions, All you really need to do is select the run you want to classify, and it'll automatically pull out all of this information. Now, note that it's not completely perfect, but you can also run this iteratively. So if it turns out that the first classification doesn't pull out everything you want, you could then run it again and make sure that you're grabbing all of the information you need for each region. Then with that said, usually, again, once you get into TBC, register it, colorize it, maybe classify, people will then kick it out into these feature extraction softwares. Now, TBC does have the capability to add in points and lines, again, similar to the MX7, but it is a very manually intensive process where you have to click on each point or essentially click along each line. Now, there are optimized softwares out there that allow you to do this much faster. And we kind of support Orbit GT, which we call TMX, but this here is actually Topodot. It's widely utilized, especially in the States. And you can see here, I mean, I think I was able to do this in a couple hours here. This is a mile stretch of project, and I was able to extract all of the power lines and poles, get road surface data, essentially spot elevations every foot along the road surface. And then another tool that actually is somewhat new development that I've really enjoyed recently is utilizing this classification here to pull out, let me hide one of the data sets that did not classify, this road surface model. So even, and for you to utilize this, the data has to be very clean, essentially. And with this, you can see even areas where you have rutting and distress in the road. Not only that, but definitely bumps and potholes as well will be picked up. But this is just one of the many tools for the feature extraction software. I just wanted to highlight this example since it was one that was delivered recently. So on that note, there is a lot of different tools that you could utilize for each application that will really streamline your process and help you become more productive. But I just wanted to give a quick run through today on not only the MX9 itself, but then some real world projects that we've been working on. And Angie, with that, I don't know if you wanted me to cover anything else or if you'd now like to pass it off to Tammy.
No, I'll pass it off to Tammy. That was great. I love looking at this data and what you can do with it. Topodot is definitely a really powerful tool.
Absolutely, yeah. It's certainly one of the most popular in the States, especially for people any type of DOT work. It's widely utilized, I believe, 37 different DOTs now. So even though the DOTs don't always have a system like this themselves, although Caltrans in California does, but they'll usually contract out this work and then bring this information in, and they have multiple operators then in Topodot that'll fly through and basically from the safety of the office be able to extract all of this information because they have, the LiDAR and the photos all ready to go from the site.
Oh, awesome. Very cool. Thank you so much, Justin. I'm going to turn it over to Tammy, and she's going to talk about Solve 3D and how it can be a valuable tool working with this data as well.
Thanks, Angie. Okay, just trying to get my screen to show. Is anything coming up yet?
Yep, I can see it, Tammy.
Okay, perfect. I'm working on 2 monitors, so I'm not sure. Are you getting the slideshow or the presenter view?
The presenter view.
Okay, let's see what we can do. Maybe we'll just leave it like this then instead of taking up a bunch of time. Okay, good morning, everyone. So Solve 3D is a suite of software applications. As Angie said, my name is Tammy Peterson, and I'm in charge of sales and marketing at the company. So a little bit about Solved, because many of you have probably not heard of us before. We are a Canadian-based company in Calgary, Alberta. We were conceptualized within a survey and engineering firm here in Calgary. They had started doing a lot of mobile mapping projects and were extremely frustrated with the tools that were available in the marketplace at the time. So they thought that they would start trying to develop something to meet their requirements, and decided that it would benefit the industry overall. So they hired a team of software developers, and in 2017, Solve became an independent entity. And then we truly began our go-to-market efforts early in 2018. So the products themselves have been around for quite some time. They're well established, completely commercialized. However, the company has only been in the market for a very short time, and hence why you may not have heard of us to date. So just a quick look at some of our partners. Of course, NEI is one of our great partners and authorized resellers, some of our technology partners, and the community affiliations and associations that we're currently involved with. And this is just a sampling of some of our users. So you can see we don't focus on any one specific industry. We serve quite across a broad swath of different industry sectors and industry verticals. And this is just to kind of visualize where we fit in the overall mix. So you would acquire data, then we have an application called Solved Engine for you to clean up and optimize that data. And then our main platform, Solved Encompass, is for visualization and collaboration. And the one thing I want to point out, this session is focusing specifically on mobile mapping products and applications. However, our software applications are meant to deal with point cloud data from any source, as well as panoramic imagery, aerial imagery and LiDAR, as well as many, many other geospatial data sets. So we'll just start into the products a little bit. So Solved Engine, as I mentioned, it's a middleware toolkit for optimizing your data before taking it into another application. So Justin had mentioned, you know, some of those applications within TopoDot where the data needs to be really clean. If you brought it into Engine, we have multiple noise filters, so that you can get rid of things like sparse noise. So if your collection happened to be done while it was raining or snowing or there was dust blowing around, you could remove all of those random particles. As well, if you're doing mobile down a road, we have one for a multi-pass where you can remove anything that's not static in the scene. So those cars, or if you're in an urban center, maybe pedestrians, people on bikes. So you can really get that data to an optimized point, so you have a nice clean data set before you start doing any of those processes and work with that data. So Solved Encompass is where I want to spend the majority of the time. Unfortunately, because our time with you is short, we won't go into a live demo, although there's a lot of videos on our YouTube channel. And if you're interested in seeing this application in depth, please contact your representative at NEI and they'll get something scheduled for you. So Encompass is a web-based platform for visualization and collaboration. So there's no special hardware or software required. All you need is a modern web browser. So whether that's Chrome, Azure, you know, you have your own web server in a data center on premise, it really doesn't matter. The data resides wherever you like. It's just the application that runs within our environment. And so no worries about having to transport copies of that data to us or jurisdiction restrictions, anything of that nature. We also support single sign-on. So for larger organizations who require that, as well, we deal with many different firewall and security issues. So a little bit about the functionality in the application. Again, completely web-based, just need a browser and you can bring together multiple types of geospatial data sets. So whether it's panoramic images, LiDAR, various types of point cloud, whether synthesized from photogrammetric, whether it is CAD models, shape files, DXF, KML, KMZ, We also support streaming web services, so WMS, WMTS, and WFS. You can also bring in your ArcGIS Online content directly into Encompass, and it brings it all together in one holistic view. Again, because all you need is a web browser and no specialized software, it's very low training curve, very quick to deploy, and it does not matter about the geographic location or level of technical expertise of the end user. So whether you need to be able to show the status of a project to your governor, or whether your marketing representative needs to get a screen grab for promotional materials for something you're working on, absolutely anyone can use this web-based platform. So just a couple of screen grabs, some of the functionality. We have various measurement ability. We have asset tagging and management. This is not an asset management system, but it allows you to visually tag and attach reference documents, videos, photos, and you can link out to anything that you can hyperlink to. So if you're already working within a web-based true asset management system, you can link the two systems together. So just a little bit about our value proposition. Again, we're trying to provide a very easy way to be able to deliver and disseminate all of this fantastic data to all stakeholders, regardless of their location or level of technical expertise. We want to ensure everyone has a common operating picture and is able to take advantage of the same spatial context as is usually reserved for GIS analysts or CAD specialists, for example. We're trying to increase the level of engagement and decision-making ability, again, by providing that holistic views of AOIs, assets, and projects, again, to anyone and everyone. And of course, as Angie spoke to earlier, with the systems and the data collection itself, we're also reducing health and safety risks and costs with fewer trips to the field, because people can operate and get a lot of that initial work done within this virtual project environment. And we're also enhancing the return on the customer's data investment. Instead of just, especially if you're someone who may not be collecting this data yourselves, but you're contracting a vendor to go out and collect data for you. Instead of just having a hard drive delivered and dumped on your desk or into a desk drawer, or just that end product that you may have contracted for, those contours, those DTMs, you can now see all of that data and you will get so much more out of it, a lot more insight and a lot of other ways to be able to use that data. So I think really that's all I wanted to cover. Unfortunately, with not being able to show you the application live, it doesn't give you a really great introduction to it. But again, we do have a number of videos on our YouTube channel. I encourage you to check those out. And again, to schedule a live demo, please contact your NEI rep. And with that, I'll pull up the last slide, Andy.
All right, thanks, Tammy. I just kind of want to make a note of, I was introduced to Tammy a couple of years ago, and Laura learned about the product. I really do think it's fantastic. Kind of a application that I've been working with Tammy and her team on, as well as a customer in Mississippi, is, it's a company that is working with a bunch of counties. And in a nutshell, they want to collect basically, every roadway in, 6 or 7 different counties. And they don't want to just use it for just basic analysis, just having that data available, disaster management. But I thought it was interesting because they took it a step further, and for their 911 dispatchers, they're working toward using Tammy's, the Solve 3D product to, give access. So when, a 911 call comes in, the dispatcher can pull up an image of that location and let the dispatchers know if there's any obstacles that could prevent them getting to that address. So, I thought that was a really, really cool application beyond what we call typical, I guess you would say. So thanks, Tammy. And I will open it up now for a few questions. And Tammy, there's one for you. We're still have you on the right now. How is the data hosted? I guess, do the customers host their own data, or how does that work?
Yeah, so that's what differentiates our product from some of the other ones out there. Regardless of what level of licensing a client has with us, they can host their data wherever they choose. So again, whether they have a requirement to be within a state data center, or something is set up on premise for a county, or if they already have an instance of Amazon or Microsoft spun up in the cloud, it really doesn't matter to us. The data just needs to be accessible on a web server somewhere. But that being said, if the client doesn't have the infrastructure or doesn't want the burden of managing and hosting that data themselves, we can provide that as a service for them.
Awesome, thanks. Justin, I've got a question that came in. I think you'd definitely be the person to answer. But when you were showing that data set, one of the attendees wants to know, just out of curiosity, what kind of point densities are you getting on those power poles?
Ooh, well, that's a great question. So on the power poles themselves, to be able to extract, and I don't know if you want to throw the screen back to me here because I can show some of it. But
yeah,
in order to extract some of this information, and again, I kind of ran through it quickly, but note I have like the radius of these poles at the bottom and the top, so that'll also give us the slants, the height, all of these things kind of built right into these feature extraction tools. But I'd say it takes at least a couple hundred points on the pole to be able to pull this out cleanly. With the MX9, this was actually 2 passes just up and down the road. And I have an example here where actually part of the QC process is seeing the deviation between point clouds and then the density. So right here, I have a density map essentially, and you can see that along the roadway, we are getting well over 10,000 points per meter in just 2 passes. Now, once you start reaching out a little further, then it's probably closer to 1,000 or 2 points per meter on those poles. But that's still an incredible amount of data that should allow you to kind of extract any of the features you might need. And that's a quick essential answer, but really it will depend on drive speed and your scan rate, which you can change on the fly in the field. And the only reason that you would ever slow down your scan rate is because essentially with this system and the Regal sensors, as you slow down the scan rate, it'll put more power per pulse. So you can actually reach out further and extend the maximum range from around 100 meters to upwards of 300 plus. So while that might not always be applicable to every application, just know that the system is versatile and you can change those kind of things in the field.
Awesome, thanks, Justin. Got another question for you too. So talking about how, what is the time, I don't know how to phrase this question. What is the time to take, like, say you collect a mile of data, what is the time in the office to extract, what is the typical time frame to extract that data?
Yeah, actually, that's a great question. So it obviously depends, but to put it simply, and some terminology here as well. So from the field, you pull the data off the drives and you're coming to process it in the office. Depending on your system, assuming that the processing computer has the right specs, we usually have a 1-to-1 ratio for processing the data. And by processing, I mean taking that raw format and creating a visualization like we see here. Now, so that means for as much time as it took me to drive down the street, it's going to take about that much time to visualize the data. Now, beyond that, to register down to control and then to colorize, classify, things like that, it will increase the amount of time. So, but for this project here, for example, I'd say it took us about 20 minutes to scan, including the initial initialization and everything. And then it probably took me an hour and a half to process and register, about 20 minutes to export, and this took me about 2 hours of extraction. So I'd say in about an 8-hour day, I went from a raw point cloud to this fully extracted and exported, essentially 2D, drawing file or line work, shape file, whatever you want to extract this in. But I went basically in a day's work, I was able to take it from the raw format and extract all of this information essentially on my own. But now TopoDot and all of the feature extraction softwares essentially have the capability for multiple people to work on projects at the same time as well. So especially in a bigger group, you can have multiple operators working in the same data set at the same time. And you can see how we've kind of tiled up this particular data set. And that's a good way to kind of split up the work as well. So yeah, even with just a single person, you can get quite a bit done in just a day's work. But again, caveats to that, where it'll depend on how the size of the project and obviously the amount of things you need to extract. If you're just trying to extract, road surface stuff and just, some assets, it likely won't take as long. But if you're trying to do a full, DTM and everything and extract all the break lines and everything that could be pulled out of the data, that'll obviously take some more time. So it's a bit variable there.
Oh, good. I like how you summarized that, Justin. That's all the questions I have. On that note, just want to thank everyone for coming. Justin, Tammy, I appreciate you being a part of this with me today. It's good to see how all the tools kind of, come together full circle. So like I said, I will be sending a follow-up email. And as soon as I can download the video, I will be sending that link out as well. So expect to get that from me within 24 hours. Again, thanks everyone. Appreciate it. And I hope you all have a great rest of your day.
All right. Thanks, guys.